Alright, so here's how the backside looks. If we do the math for NO3, we find that we need 4 bonds. Nitrogen in the middle, surrounded by 3 oxygen, single bond to all of them, and then just choose one of them to have a double bond to get use of our 4th bond. We do our ABE. Well, the other thing we need to do is make sure that this thing has a charge, so we got to put the whole thing in brackets with a -1 there. We have a negative charge. It means we've got 1 extra electron. That's where this guy's coming from down there. So now our ABE, A is our central atom. It's bound to 3 different atoms. Same element, but different atoms. And there's no lone pairs of electrons. We don't need any because nitrogen has enough electrons to make it happy. And then AB3 corresponds to trigonal planar. And then if we find the bond between the nitrogen and the oxygen, the polarity of that bond is polar. But as we go down the chart, our flow chart, the molecule itself is not going to be polar because there are no lone pairs on our central atom, and it's bound. The central atom is bound to the same elements. If we take a look at the second one, remembering hydrogen just is happy with 2 valence electrons, we find that we need 3 bonds. If we do this, we're going to have oxygen in the center, 3 hydrogens around it, single bonded to the oxygen, and we're going to need a pair of electrons down here on the oxygen. Our ABE notation is bound to 3 different atoms, and there are a lone pair of electrons on our central atom, so that's where the E comes from. If we look up our shape, that's going to be trigonal pyramidal. And if we look at our polarity, the only bonds that we have are oxygen to hydrogen. Oxygen's electronegativity is 3.5. Hydrogen's is 2.1. That's going to give us a difference of 1.4. That bond is very polar, but may or may not be a polar molecule. So if we go down our flow chart, first question, is there a polar bond? Yep. Are there lone pair electrons in a central atom? You betcha, right here. And then that tells us that it is polar. So that's a polar molecule. If we look at ClO3, math tells us we need 3 bonds. Looks very similar to the one above it, chlorine in the middle, 3 oxygens surrounded it by connected with single bonds, and a pair of electrons to make chlorine happy. Our ABE notation is going to be the same as the one above it because we have a central atom, 3 atoms attached to it, and a pair of electrons attached to it. The shape, therefore, is going to be the same as the one above it, trigonal pyramidal. And then we got to look to see if it's polar. Our chlorine to oxygen bond gives us a difference of 0.5 in our electronegativities. And that corresponds to a polar bond, but if we go through our flow chart, we find that there is a polar bond. There are lone pair electrons in our central atoms, therefore the molecule itself is polar. If we look at NO2, down here we find that we're going to need 3 bonds for this one, but we only have 2 atoms to bond to the nitrogen, so one of those bonds has to be a double. Again, because it's an ion, all the ones on this back page are ions. They need to go in brackets with the charge outside of it. Our ABE notation, well, our central atom is going to be A. It's bound to 2 different atoms. There's our AB2, and there are a single pair of electrons on the central atom, so therefore we have AB2E. That corresponds to a bent shape. Our difference in electronegativities gives us 0.5, so it's just barely polar, those bonds. And if we go through the flow chart, is there a polar bond? Yes. Are there lone pair electrons in the central atom? Yep. Is the central atom bound to at least 2 different elements? No. So, sorry, I didn't even need to go down that way. Are there lone pair of electrons in the central atom? There are, and therefore it is polar. And then the last one, NH2, we have our, do the math, end up with 2 bonds. Nitrogen in the middle, hydrogen on each side. Let's connect them with single bonds and fill out the nitrogen's full octet. Give it 8 electrons in the outer shell, so we've got 2 pairs of non-bonding electrons. Come over to our ABE notation. We have A is our central atom, 2 atoms bound to this, gives us AB2, and then we've got 2 pairs of electrons just hanging on the nitrogen, not part of the bonds. And that gives us an E2, and that corresponds to bent as well. Now, looking at the polarity, these bonds between the nitrogen and the hydrogen are polar bonds. So therefore, we go in our flow chart. Are there polar bonds? Yes. Are there lone pair electrons in the central atom? There are. So that's how we end up with what we end up with, that molecule being polar. Cool. That's how this is done.